Okay, curve sketching. So curve sketching, the problems look like this. Graph the function considering domain, critical points, increasing and decreasing sections, inflection points, concavity, intercepts, and asymptotes. Do you have to look at all of that? Absolutely not. Do the least amount possible to pick your graph. In fact, this problem that was on the test, you don't even need to use calculus to pick your graph. So this is the function. So the problem is multiple choice. So the first thing I did was factor out my denominator. So I got an x minus 3 and an x plus 3. I notice that my denominator equals 0 at 3 and negative 3. So those are vertical asymptotes. So I've already narrowed my choices down to just A and C. I tried to kind of sketch them because of the asymptotes, because the other two graphs were continuous and never stopped. So I ruled two choices out. Then the only other thing I did was, this was the difference in my graph, right? I notice in this section here, it's positive, and in this section here, it's negative. So I picked an x value that I knew would be in this section and just calculated what the value was. So I plugged in 5, because the vertical asymptote here is at 3, so I picked a number greater than 3. I plugged in 5, and I get 30 over 16, 2 times 8, which is roughly 2, but it's positive. So I know in this section I need to have a positive graph. So I've picked this graph and I've done absolutely no calculus. Do the same if you can, it just makes it easier. Okay, our next section was absolute extrema. So the problems on the test, this is the one y'all struggled with the most, and it was mostly because of the fractions. So just be careful with fractions. It says find the absolute max and min values of each function over the indicated intervals. So here's our function, and here is our interval. I wrote out the question here, and I filled in the blank after I did the problem, but it says the absolute max value is blank at x equals blank. I wanted you to get that this is going to be the y value, this is the x value. Then they did the same thing for the min. So what I did was I took the derivative to find where the relative max and mins occur. It's where my derivative is 0. So I took my derivative, I factored my points where my derivative equals 0 is at a negative 1/3 and at 1. The 1 isn't in the interval, so I don't even bother with it after this point. Then I make sure I evaluate the x values in the interval and my endpoints. So I use f of negative 1/3, and then I pick my endpoints, negative 1 and 0. I evaluate my function at all of these points, and I get that f of negative 1/3 is 275 over 27. Y'all can do the math, which is roughly 10.2. F of negative 1 is 9, and f of 0 is 10. So this is my min, this is my max, and that's what I plug back in up here. I have one more absolute extrema problem for you, and then we're going to move on. It's the disease one, so I've written it out for you. It's the P of t equals 12t e to the negative t over 7. Remember, guys, I've written it all out. I've done the derivative. You can go over it. But the shortcut here is whatever this number in the denominator here is, that's what your t value is going to be. It has always turned out to be this answer. You can go through the whole process, and I've done it here so you can read it. Again, it's an absolute max problem where you're supposed to plug in the endpoints and where the derivative equals 0, but it usually always turns out to be this number. It's a product rule, and the product rule has some tricky factoring, so I put it in here. But just so you know, if you get this problem, it's going to be that number in the denominator. And I've shown you here. And it occurs at 7 days, and it's 30.9%. Email me questions on that one if you have it. Okay, guys.